Hello everyone. Today we will discuss the model answer of first terminal examination question paper for 12th science of the subject physics. Some general instructions are given in question paper. Question paper is divided into 4 sections named as A, B, C, D. All sections are compulsory for solving the question papers. Section A consists of 2 questions. Question number 1, question number 2 carries 1 mark each. So total mark for first terminal examination will be 14. Section B consists of 11 questions which are of short answer 1 type questions. Only 8 questions can be solved. Each question carry 2 marks. So section B carries 16 marks. Section C consists of 6 questions which are of short answer to second 2 type. Only 4 questions can be solved. Each question carry 3 marks. So section C carries 12 marks. And section D consists of 4 questions which are of long answer type. Only 2 questions are solved. Each carries 4 marks. So first terminal examination question paper total marks will be 50, can be solved in 2.5 hours. First, we will see section A. So question number 1 is select and write most appropriate answers from the alternative multiple choice question MCQ type. So first question is the angular momentum of system of a particle is conserved. Its option will be option A, when no external force acts upon the system. Option B, when no external torque acts upon the system. Option C, when no external impulse acts upon the system. And option D, when axis of radiation remains the same. So answer for the question 1 will be option B, when no external torque acts upon the system. Because using the law of conservation of angular momentum of system of a particle is constant. Therefore, dl upon dt will be constant, where L is angular momentum. When torque τ will be constant, we know that torque τ is equal to I alpha, where alpha is angular acceleration. So alpha is equal to d omega upon dt. So torque becomes I d omega upon dt, means derivative with respect to time d upon dt in bracket I omega, and angular momentum will be L equal to I omega. Therefore torque equal to dl upon dt. If torque τ equal to 0, then dl upon dt will be constant. That will be the answer. Question number 2. The average kinetic energy per molecule is proportional to option A, the pressure of gas, option B, the volume of gas, option C, the absolute temperature of gas, and option D, the mass of gas. So answer of the question will be option C, the absolute temperature of gas. Because we know the pressure exerted by gas is pressure P equal to 1 upon 3 rho C square RMS, where rho is density is equal to mass upon volume. So pressure P equal to 1 upon 3 in bracket m upon v C square RMS. Therefore 3PV is equal to m into C square RMS. If we multiply half on both sides, so 3 by 2 PV is equal to half m CRMS square, where capital M equal to small m n. So for perfect or ideal gas, PV equal to RT. Therefore 3 by 2 RT is equal to half mn C square RMS, which is equal to kinetic energy per mole. So if 3 upon 2 R is constant, where R is universal gas constant, so we can say that kinetic energy per mole is directly proportional to absolute temperature. That will be the answer. Question number 3. At mean position, acceleration of particle performing linear SHM is option A infinity, option B varies, option C maximum, and option D 0. So the answer of above question will be option D 0, because we know acceleration of a particle performing SHM is omega square x. At mean position, if x equal to 0, then acceleration of particle will be 0. So answer is 0. Question 5. Kirchhoff's second law in bracket voltage is based on option A conservation of charge, option B conservation of mass, option C conservation of energy, and option D conservation of momentum. So answer for the above question will be option C conservation of energy, because algebraic sum of EMF or energy per unit charge corresponds to the electric energy supplied by the source. According to law of conservation of energy, energy must appear in the form of electric potential difference across the electric element in the loop, which leads to law of voltage. So answer is option C conservation of energy. Question 6. Work function of metal surface is 4.2 electron volt. Its threshold wavelength will be option A 3959 angstrom unit, option B 3500 angstrom unit, option C 2959 angstrom unit, and option D 2500 angstrom unit. This question is numerical based, so answer of the question will be option C 2959 angstrom unit, because we can use the formula phi is equal to h nu, or work function is equal to h nu, where nu is frequency. So formula will be phi equal to hc upon lambda. If we substitute the value of h, that is 6.63 into 10 raised to minus 34 joule second, and c is velocity of light, will be 3 into 10 raised to 8. And if we substitute, your answer will be 2.960 into 10 raised to minus 7 meter. And therefore, the answer which is approximately given as 2959 angstrom unit. So answer will be 2959 angstrom unit. Another numerical based question, question number 7, is in a hydrogen atom, electron jumps from 4th orbit to 2nd orbit. The wave number of radiation will be option A r upon 16, option B 3 capital R upon 16. Option C, 5 capital R upon 16. And option D, 7 capital R upon 16. So answer for the above example will be option B, 3 capital R upon 16, because electron jumps from fourth outer orbit, so n equal to 4, and inner orbit, second inner orbit, so p equal to 2. So wave number 1 upon lambda equal to question mark. So formula will be 1 upon lambda equal to capital R in bracket 1 upon p square minus 1 upon r square. If we substitute value of r and p and n, so you get answer wave number will be 3 capital R upon 16. Question number 2. Answer the following question. In this, question number 1 will be what is the shape of wavefront on the earth for sunlight? So answer is when light from the sun reaches on earth surface, then wavefront is formed in the form of plane wavefront, because a wavefront which is obtained at infinite distance from the source is called plane wavefront. So the shape of wavefront on earth for sunlight is plane wavefront. Question number 2. What is the difference between conical pendulum and simple pendulum? Here one column is simple pendulum, another column is conical pendulum. The first point, in simple pendulum, the oscillation of bob are in vertical plane, whereas first point, in conical pendulum, the bob performs uniform circular motion in a horizontal plane, and string made or string traces a cone of constant semi-vertical angle. In simple pendulum, second point will be the time period of simple pendulum depends on length of string and acceleration due to gravity. So capital T equal to 2 pi square root of L upon G. Whereas in conical pendulum, the time period of conical pendulum depends on length of string, comma, acceleration due to gravity and cosine the semi-vertical angle, that is cos theta. Therefore, capital T equal to 2 pi square root of L cos theta upon G. Any one difference, it gets 1 mark. Question number 3. How energy must be supplied to hydrogen atom to free or remove the electron in ground state? Answer will be, we know total energy of electron in hydrogen atom is capital En is equal to minus m z square e raised to 4 upon 8 epsilon 0 square h square n square. Therefore, minimum amount of energy which is used to remove or to free the electron from ground state or for ground state, n is equal to 1. So called binding energy. So binding energy equal to minus of total energy. So binding energy equal to minus of m z square e raised to 4 upon 8 epsilon 0 square h square. For hydrogen atom, z equal to 1. So binding energy is m e raised to 4 upon 8 epsilon 0 square h square. That energy must be used to hydrogen atom. Question number 4. What is stopping potential? Answer will be, it is the magnitude of retarding potential for which photoelectric current is zero, called stopping potential, or it is the value of retarding potential difference that is just sufficient to stop the most energetic photoelectron emitted from reaching the collector, so that photoelectric current in a photocell reduce to zero, called stopping potential. Question 5 is numerical base. So, question 5 is velocity of three molecules of 1 kilometer per second, 3 kilometer per second, 5 kilometer per second. Find mean square velocity. So, given data is C1 equal to 1 kilometer per second, C2 equal to 3 kilometer per second, and C3 equal to 5 kilometer per second. And we can find out C square mean or square mean square velocity question mark. So, formula it will be mean square velocity C square mean equal to C1 square plus C2 square plus C3 square divided by 3. If we substitute the values of C1, C2 and C3, so answer will be 35 upon 3 kilometer per second, means 11.66 or 11.67 kilometer per second. That will be the answer. Another numerical base question, question number 6 is find the period of particle performing linear simple harmonic motion. If amplitude and maximum velocity of particle is 3 meter and 5 meter per second. So answer which is given data. So time period t equal to question mark, a is given 3 meter and velocity maximum is 5 meter per second. We know the formula V maximum equal to A omega, and therefore omega equal to V maximum upon A, which is 2 pi upon capital T. Therefore capital T equal to 2 pi A upon V maximum. If we substitute the values, time period is 6 pi upon 5 second. If we substitute pi 3.142, so answer is 3.7704 second. So time period of a particle performing linear simple harmonic motion is 3.7704 second. Question number 7, also numerical base. This question is what is the magnetic susceptibility if magnetization of bar magnet is 3.3 into 10 raised to minus 4 ampere per meter and magnetic intensity is 1.1 into 10 raised to minus 4 ampere per meter. So here answer will be given data, that is magnetic susceptibility xi m is equal to question mark. So magnetization mz is given 3.3 into 10 raised to minus 4 ampere per meter and magnetic intensity capital H is equal to 1.1 into 10 raised to minus 4 ampere per meter. We know the relation, that relation will be mz magnetization is equal to magnetic susceptibility xi m into magnetic intensity. Therefore magnetic susceptibility xi m is equal to magnetization upon magnetic intensity. If we substitute the values, so magnetic susceptibility is equal to 3. Section B. Attempt any 8 of the following questions. So question number 3 in section B will be derive an expression for maximum safety speed with which vehicle should move along a curved horizontal road. State the significance. So answer will be, consider a vehicle of mass m is moving with velocity v along a horizontal curve road of radius of curvature r. Let mu0 is coefficient of friction of road surface and tire of vehicle. Therefore, limiting force of frictional force is equal to mu capital N, where capital N is normal reaction, that will be mu into mg. So, if V maximum is maximum safety speed of vehicle, then for circular motion centripetal force is necessary, which provides frictional force. So centripetal force equal to frictional force, which is m into v square of maximum upon r equal to mu mg. If get cancel, so v square maximum equal to mu rg. Therefore v maximum is equal to square root of mu rg, which is the required equation for expression of maximum safety speed. So the significance is, above expression shows maximum velocity changes or depends on friction. Friction changes the circumference. Therefore, the nature of surface and presence of oil or water on road surface. If friction is not sufficient to provide the centripetal force, then vehicle is skid off. The road is in rainy season, but when oil drop, or in rainy season when oil drop is on surface of road, in rainy season oil is sprayed on road surface, so moving vehicle is skid off on the road. Question number 4. Show that CRMS is directly proportional to square root of capital T, where capital T is absolute temperature of gas. Here answer is, we know pressure exerted by gas on the basis of kinetic theory of gases. P equal to 1 upon 3 rho c square RMS, where c RMS is RMS velocity, rho is density of gas, which is mass upon volume. So P equal to 1 upon 3 m upon v c square RMS. Therefore c square RMS equal to 3 PV upon capital M. For ideal gas, PV equal to RT, so C square RMS equal to 3 RT upon capital M. If we take square root on both sides, so C RMS is equal to square root of 3 R upon M into capital T. If R and M is constant, so C RMS is directly proportional to square root of capital T, which is proved. Question number 5. State any two law of simple pendulum. So answer is, we know the period of simple pendulum is capital T equal to 2 pi square root of L upon G, where capital L is length of simple pendulum and G is acceleration due to gravity at place. So law of simple pendulum state that, number 1, law of length. The period of simple pendulum at a given place, if G is constant, is directly proportional to square root of length of simple pendulum. Therefore, capital T directly proportional to square root of L if G is constant. Second law, law of acceleration due to gravity. The period of simple pendulum at a given place, length is constant is inversely proportional to square root of acceleration due to gravity. Therefore, if capital L is constant, then capital T directly proportional to or inversely proportional to square root of g, 1 upon g. Question number 6. Define magnetization and magnetic intensity. So answer is first magnetization. The net magnetic moment per unit volume of a material is called magnetization of material. Therefore, mz is equal to m net upon v. Second thing, magnetic intensity. The magnetic intensity is defined as the magnetic induction in an isotropic medium is divided by permeability of medium. So, vector H is equal to vector B upon mu, where mu is permeability of medium. Vector H is magnetic field intensity and vector B is magnetic field induction. Question number 7. State any two postulates in Bohr's theory of hydrogen atom. Answer is, in hydrogen atom, only one electron is present in outermost orbit. So postulates of Bohr's theory of hydrogen atom is: first postulate, in outermost orbit of hydrogen atom, electron is revolved around the nucleus in a circular orbit. For circular motion, centripetal force is necessary, which provides the electrostatic force between nucleus and electron. Therefore, centripetal force is equal to electrostatic force. Therefore, mv square upon r is equal to 1 upon 4 pi epsilon 0 e square upon r square, where m is mass of electron, v is velocity of electron, e is charge on nucleus, minus e is charge on electron, and r is radius of circular orbit. Second postulate, electron can revolve without radiating energy. Only its certain orbit is called allowed or stable orbit, in which angular momentum of electron is integral multiple of h upon 2 pi. Therefore, angular momentum of electron is equal to nh upon 2 pi, where h is Planck's constant. Question number 8. Give the difference between ammeter and voltmeter. First of all, we know that galvanometer is used as ammeter as well as voltmeter. So, two columns, ammeter and voltmeter. So, first point is ammeter measures the current, whereas in voltmeter measures the potential difference. Number 2, when galvanometer is connected in series with a resistance of circuit in ammeter. In voltmeter, galvanometer is connected in parallel with resistance of circuit. An ammeter should have very low resistance. For ideal ammeter, resistance is 0, whereas voltmeter should has high resistance. Ideally, voltmeter has infinite resistance. The range of ammeter can be increased by decreasing the value of shunt resistance, which is connected in parallel to the galvanometer. Here, In voltmeter, the range of voltmeter can be increased by increasing the high value resistance, which is connected in series to the voltmeter. Last point is resistance of ammeter RA is equal to S G upon S plus G, where S is shunt resistance and G is resistance of galvanometer, which is G upon N, whereas resistance of voltmeter is RV equal to G plus RS, where G is resistance of galvanometer and RS is high resistance connected in series, which is equal to G into N. Question number 9. Define threshold frequency and threshold wavelength. First we see threshold frequency. Threshold frequency for a given metal surface is minimum frequency of incident radiation below which there is no photoelectric or no photoelectrons are emitted from metal surface, and above which photoelectrons are emitted from metal surface. Such frequency is called as threshold frequency. Threshold frequency denoted by nu zero. If nu is less than nu zero, there is no photoelectrons are emitted. But if nu is greater than nu zero, there is emission of photoelectrons. The second term, that is threshold wavelength. Threshold wavelength for a given metal surface is maximum wavelength of incident radiation above which no photoelectrons are emitted from metal surface, below which photoelectrons are emitted. It is represented by lambda 0. If lambda is greater than lambda 0, there is no photoelectrons are emitted. But if lambda 0 is greater than lambda, there is photoelectrons are emitted. A numerical based question number 10 is two coherent sources of light whose intensity ratio is 25:1 produce interference fringes. Calculate the ratio of amplitude of light wave coming from them. So answer is, first of all, in question given data, that is I1 upon I2 is equal to 25/1, and we can find A1 upon A2. So first we know that I directly proportional to A square, where A is amplitude, I is intensity. Therefore we can write I1 upon I2 is equal to A1 square upon A2 square. If we take square root on both sides, then we can write A1 upon A2 equal to square root of I1 upon I2. If we can substitute the values of I1 upon I2, then A1 upon A2 is equal to square root of 25/1. Therefore, A1 upon A2 is 5/1. So, ratio of amplitude of two light wave is 5:1. Means formula get half mark, substitution get half mark, and correct answer will get 1 mark. Another numerical based question, question number 11. Four resistances 6 ohm, 6 ohm, 6 ohm and 18 ohm are formed a Weston's network. Find the resistance which is connected across 18 ohm. So we'll balance the network. So given answer will be there. Given data R1, R2, R3, 6 ohm, 6 ohm, 6 ohm, and R4 is 18 ohm. And we can find out the value x equal to question mark, which is connected across 18 ohm. Let x is the resistance which is connected across 18 ohms in parallel. Therefore, 1 upon R4 is equal to 1 upon 18 plus 1 upon x. Then we can write R4 is equal to 18x upon 18 plus x. Suppose this is equation number 1. For balancing condition, we can take R1 upon R4 is equal to R2 upon R3. Substitute the values, 6 get cancelled, so R4 is equal to 6 ohm. From equation 1 and from equation 2, they are equalized, so we can find out the value of x, and the value of x is 9 ohm. That is the answer for given question. Numerical based another question is question number 12. Find the number of photons in radiation. If the total energy of radiation of frequency 10 raised to 14 Hertz is 6.63 Joule. Here for answer, first of all we can write given data. So number of photons n equal to question mark. Here energy is given having value E equal to 6.63 Joule. Frequency is given having value nu equal to 10 raised to 14 Hertz. We know the term Planck's constant H, which has value 6.63 into 10 raised to minus 34 Joule second. So here according to Planck's quantum theory, energy E equal to nh nu. So n equal to E upon h nu. So here if we substitute the values, so n is 10 raised to 20. That is the number of photon in radiation. Another numerical based question, question number 13. It is find the moment of inertia of a rotating body if torque acting on body is 200 Newton meter and angular acceleration of body is 50 radian per second. Here answer, first of all we can write data. I, moment of inertia I equal to question mark, given torque tau equal to 200 Newton meter and angular acceleration alpha equal to 50 radian per second. We know using the relation between torque and angular acceleration, torque tau equal to I alpha, therefore I equal to torque upon alpha. If we substitute the values, you get moment of inertia of rotating body equal to 4 kg meter square. Section C. Attempt any 4 of the following. So in section C, first we see question number 14. The question is find expression for pressure exerted by gas on the basis of kinetic theory of gases. So answer is, first, consider gas enclosed in a cube, each side of cube having length L. So volume of cube equal to L cube. Therefore volume of gas is equal to volume of cube, which is equal to L cube. Let capital M is mass of gas. Gas consists of capital N number of molecules. So mass of each molecule is small m. Therefore capital M is equal to small m into capital N, means number of molecules. So we know that rho is the density of gas, so rho equal to mass of gas upon volume, m upon v. Here we can also write rho equal to m capital N upon L cube. Consider gas molecules. These gas molecules are randomly moving with different velocity. Let C1, C2, C3 Cn upon 3 be the velocity of gas molecules. Consider the first molecule of gas having mass m moving with velocity c1. So, momentum for first molecule before collision will be m into c1, where molecule is collide with wall S, then molecule rebound. So, from the surface moving with velocity minus c1. So, momentum of gas molecule after collision is equal to minus mc1. Therefore, change in momentum is equal to momentum after collision minus momentum before collision. Let change in momentum equal to minus mc1 minus mc1, which is equal to minus 2mc1. Therefore, change in momentum equal to 2mc1 in magnitude. Using Newton's second law of motion, rate of change in momentum is equal to force. So, change in momentum upon time equal to force. So, therefore, change momentum is 2mc1 upon time t equal to force F1. Between successive collision in time t second, particle cover with distance 2l. So, velocity c1 equal to 2l upon small t, and therefore small t equal to 2l upon c1. So, F1 equal to 2mc1 upon 2l upon c1, and which is equal to mc1 square 2mc1 square upon 2l. 2 get cancelled. So, force acting on first molecule F1 is equal to mc1 square upon L. Similarly, force acting on second molecule F2 equal to mc2 square upon L. In three-dimensional coordinate system, molecule is moved along x-axis, along y-axis and along z-axis. So, total capital N upon 3 number of molecules are there. So, force acting on N upon 3 molecule. So, F N upon 3 equal to M C N upon 3 square upon L. Therefore, total force acting on closed cube or enclosed in a cube is F N upon 3 equal to F1 plus F2 plus F3 plus F N upon 3, which is equal to mc1 square plus L mc1 square upon L plus mc2 square upon L plus mc3 square upon L plus mcn upon 3 square upon L. If m upon L is common, so m upon L in bracket c1 square plus c2 square plus c3 square plus c square n upon 3. We know that c bar square, that is mean square velocity, which is equal to c1 square plus c2 square plus c3 square plus c square n upon 3 upon n upon 3, which is c square RMS. Therefore, C1 square plus C2 square plus C3 square plus C square n upon 3 equal to n upon 3 C square RMS. If we substitute the value of n upon 3 C square RMS, then total force F equal to m upon L n upon 3 C square RMS. We know that pressure exerted by gas P equal to force upon area. So pressure equal to 3n upon L mn upon 3L C square RMS upon L square. So m upon 3L cube C square RMS. We know that P pressure equal to 1 upon 3 m upon V C square RMS, that is rho. So 1 upon 3 rho C square RMS, which is the expression for pressure exerted by gas on the basis of kinetic theory of gases. Question number 15. Explain domain theory on the basis of ferromagnetic substance. So answer for this question will be, first of all, we seen domain theory is explained on the basis of ferromagnetic substances. Ferromagnetic substance consists of large number of small region. Each region is called as domain. Different domains are oriented in different directions. Size of each domain is about 10 raised to minus 6 meter to 10 raised to minus 4 meter. Each magnetic substance consists of 10 raised to 10 up to 10 raised to 17 number of atoms. Boundary of each domain or region is called domain wall. Normally, in case of normal state. In normal state, all domains have their magnetic moments are oriented in different directions. So, different domain are oriented in different directions. So, their resultant magnetic moments of whole magnetic substances will be zero as shown in figure. But if we apply weak magnetic field, when weak magnetic field is applied, then due to this weak magnetic field, domains whose direction of orientation magnetic moment is same to the applied magnetic field, such domains are try to reduce the size of another domain by shifting the domain wall as shown in figure. By replacing the magnetic field or by removing the applied weak magnetic field, then all domains comes to normal states. By reducing the size of domain whose direction of orientation of magnetic moment is same to the applied weak magnetic field. But if we apply strong magnetic field, when strong magnetic field is applied, then all domains are aligned in same direction of applied magnetic field, so that magnetic field or magnetic moments is non-zero. Ferromagnetic substance of all domains are moved from weaker part to strong part in the direction of applied magnetic field as shown in figure. But If applied magnetic field is removed or replaced, then the domains are not comes in normal state and net magnetic moment is non-zero. So ferromagnetic substance becomes permanent paramagnetic substance or paramagnet. This domain theory is explained on the basis of ferromagnetic substance. Question number 16. Describe the potentiometer is used to compare EMFs of two given cells individually. Answer will be potentiometer consists of several meter long uniform wire stretched between two terminals on a wooden board, calibrating a scale. Across two terminals, a cell or battery is applied through a rheostat which controls the current in potentiometer. A galvanometer is connected at one end of terminal of potentiometer. Also, connect a jockey which is slide on potentiometer wire. At point D, galvanometer shows null deflection. Measure length between terminal to the point D is L as shown in figure. According to principle of potentiometer, EMF E directly proportional to length L. So E capital E equal to I sigma L or I rho L, where rho is constant or resistance per unit length. Two given cell, Leclanché and Daniell cell, have EMF E1 and E2. Their positive terminals are or to the two given cell to positive terminals of rheostat and negative terminals of both cells are connected to two-way key. Middle terminal is connected to galvanometer and free terminal of galvanometer is connected to jockey which is slides on potentiometer wire as shown below. When key K1 is closed, cell E1 is in working. By sliding jockey at point D dash, galvanometer shows null deflection. Measure length AD dash. So, using principle, E1 is directly proportional to L1. So, E1 equal to I rho L1. When key K2 is closed and key K1 is open, cell E2 is in working. By sliding jockey, galvanometer shows null deflection. Measure length AD dash is L2, which is balancing length of Daniell cell E2. Therefore, E2 is directly proportional to L2. So, E2 equal to I sigma L2 means equation 3 and equation 4 when they are divided with each other, E1 upon E2 equal to I sigma L1 upon I rho L1 upon I rho L2. I rho get cancel. Therefore, E1 upon E2 equal to L1 upon L2. Using this formula, we can compare EMF of two given cell individually. Question number 17 is based on numerical. Refractive index of glass and water with respect to air is 3 upon 2 and 4 upon 3 respectively. What will be the refractive index of glass with respect to water, and what will be refractive index of water with respect to glass? Also find the difference between two refractive indices. Answer for this numerical: given data, mu for glass with respect to A 3/2, mu for water with respect to A 4/3. We can find mu for glass with respect to water, mu for water with respect to glass, and mu for glass with respect to water minus mu for water with respect to glass equal to question mark. First of all, we see mu for denser medium with respect to air medium equal to velocity of light in air upon velocity of light in denser. So first of all, we have seen mu for glass with respect to air is equal to velocity of air upon velocity of glass. Therefore, velocity of glass equal to velocity of air upon mu for glass with respect to air. Equation 1. Mu for water with respect to air equal to velocity of light in air upon velocity of light in water. So, velocity of light in water equal to VA upon mu for water with respect to air. Therefore, we can find mu for glass with respect to water is equal to V water upon V glass. If we substitute, so mu for glass with respect to water is 9 upon 8 is becomes 1.125, whereas mu for water with respect to glass equal to Vg upon Vw. So if we substitute, then answer will be refractive index for water with respect to glass is 8 upon 9, that is 0.8888. Their difference, mu for glass with respect to water minus mu for water with respect to glass, if we substitute the values, their answer will be 0.236. Another numerical based question, question number 18. A particle performing simple harmonic motion has velocities 8 cm per second and 6 cm per second at a displacement of 3 cm and 4 cm respectively. Calculate the amplitude and the period of simple harmonic motion. Given data, V1 is equal to 8 cm per second, V2 equal to 6 cm per second, x1 equal to 3 cm, x2 equal to 4 cm, amplitude A equal to question mark, time period T equal to question mark. First, we will see velocity of particle performing linear simple harmonic motion. V equal to A square root of omega square minus x square. For first particle, V1 equal to A square root of omega square minus x1 square. Equation 1. V2 for second particle, V2 equal to A square root of omega square minus x2 square. Equation number 2. If we divide equation 1 and 2, what happen? V1 upon V2 equal to A square root of omega square minus x1 square upon A square root of omega square minus x2 square. A get cancel. So we square the equation on both sides. V1 upon V2 square equal to omega square minus x1 square upon omega square minus x2 square. If we substitute the values, then here the values will be 64 upon 36 equal to omega square minus 9 upon omega square minus 16. Their dividation, 16 upon 9 equal to omega square minus 9 upon omega square minus 16. If we calculate, so here answer will be 7 omega square equal to 175. Omega square is equal to 175 upon 7. If we divide, it is 25. So omega equal to 5 radian per second. If we substitute the value of omega in equation 1, 8 equal to A square root of 5 square minus 3 square. 8 equal to A square root of 25 minus 9. So equal to A square root of 16. So 8 equal to 4a. So a equal to 2 centimeter. So amplitude is 2 centimeter. We know that time period t equal to 2 pi upon omega. If we substitute the value of omega 5, so capital T equal to 2 pi upon 5, which is 0.4 into pi. If we substitute the value of pi, 0.4 into 3.142, so answer will be 1.2568. So time period will be 1.2568 second. Another numerical based question number 19. A railway track goes round a curve having a radius of curvature of 1 kilometer. The distance between the rail is 1 meter. Find elevation of outer rail over inner rail. So there is no side pressure against the rail when a train goes round the curve at 36 km per hour. So answer will be given data radius r equal to 1 kilometer, which is equal to 1 into 1000 meter. We can find elevation means theta equal to question mark. Velocity is given v equal to 36 km per hour, that is 10 meter per second, and small g is equal to 9.8 meter per second. We know for angle of banking the formula tan theta equal to v square upon rg. If we substitute the values, then for finding tan theta equal to 0.01020. So here 0. The 36 minute. Elevation of outer rail over inner rail is 0 degree 36 minute. That is the answer of given numerical. Section D. Attempt any two of the following. Question number 21. Find the expression for total energy of electron in Bohr's theory of hydrogen atom. Answer will be, first, in Bohr's theory of hydrogen atom, only one electron is present in outermost orbit. Let minus E be the charge on electron, plus E be the charge on nucleus. Small r be the radius of circular orbit, v be the velocity of electron, and small m is mass of electron. If we see, according to first postulate of Bohr's theory, for circular motion, centripetal force is necessary, which provides electrostatic force between nucleus and electron. Therefore, centripetal force is equal to electrostatic force mv square upon r equal to 1 upon 4 pi epsilon 0 e square upon r square in magnitude. So r get cancel. Therefore, mv square equal to 1 upon 4 pi epsilon 0 e square upon r. If we multiply half on both sides, so half mv square is equal to half into 1 upon 4 pi epsilon 0 e square upon r. And so kinetic energy of electron is equal to 1 upon 8 pi epsilon 0 e square upon r. Equation number 1. We know amount of work in bringing unit charge from infinity to that point called electric potential. Force acting on charge minus E, then charge is displaced by distance dr. So work is done. Work done equal to force upon charge multiplied by small displacement. 1 upon 4 pi epsilon 0 e square upon r square multiplied by dr upon e in magnitude. So E get cancel, 1 upon 4 pi epsilon 0 multiplied by E in bracket dr upon r square, that is work done dw. For finding amount of work, take integration on both sides. Integration dw equal to 1 upon 4 pi epsilon 0 E integration of dr upon r square, which is equal to 1 upon 4 pi epsilon 0 E integration of r raised to minus 2 into dr. So amount of work is equal to E upon 4 pi epsilon 0 r raised to minus 2 plus 1 upon minus 2 plus 1. Therefore, electric potential is equal to minus 1 upon 4 pi epsilon 0 E upon r. This amount of work is stored in the form of potential energy. So, potential energy equal to minus 1 upon 4 pi epsilon 0 E upon r is equal to minus 1 upon 4 pi epsilon 0 E square upon r. Equation number 2. We want to find total energy. So, total energy equal to kinetic energy plus potential energy equal to 1 upon 8 pi epsilon 0 E square upon r minus 1 upon 4 pi epsilon 0 E square upon r. If we take common 1 upon 4 pi epsilon 0 E square upon r in bracket 1 by 2 minus 1. If we calculate, so total energy of electron will be minus 1 upon 8 pi epsilon 0 E square upon r. But we know radius of orbit r is equal to epsilon 0 h square upon pi me square bracket close into n square. If we substitute the value of r, then total energy of electron is minus me raised to 4 upon 8 epsilon 0 square h square n square. That is the formula for total energy of electron in Bohr's theory of hydrogen atom. Question number 21. Find the expression for bandwidth. Show that bandwidth for bright band and for dark band is equidistant. So answer for this question will be, let us consider two sources of light S1 and S2 are separated with distance r, and screen is placed at distance capital D from S1 and S2. Draw perpendiculars from S1 on screen at M. Also draw a perpendicular from S2 on screen at N. And draw a perpendicular from center of S1 and S2 on screen at O. So distance OM and distance ON is D upon 2. Let any point P on screen at distance x from O join S1P and S2P, forming the two triangles as shown in figure. In figure, two triangles are right angle triangle. They are triangle S1MP and triangle S2NP. In triangle S1MP, S1P square equal to S1M square plus MP square. But OP equal to OM plus MP, so MP equal to OP minus OM. So MP equal to x minus D upon 2. The above equation becomes S1P square equal to capital D square plus in bracket x minus D upon 2 bracket square. S1P square equal to capital D square plus in bracket x square minus 2xd upon 2 plus d square upon 4. 2 get cancel. So S1P square equal to d square plus x square minus xd plus d square upon 4. Equation number 1. In triangle S2NP, S2P square equal to S2N square plus NP square. We know NP equal to ON plus OP. So NP equal to X plus D upon 2. Therefore X2P square equal to capital D square plus X plus D upon 2 bracket square equal to D square plus X square plus 2XD upon 2 plus D square by 4. 2 get cancel. S2P square equal to D square plus X square plus XD plus D square by 4. Equation 2. If equation 2 minus equation 1 is there, then S2P bracket square minus S1P bracket square equal to D square plus X square plus XD plus D square by 4 minus D square minus X square plus XD minus D square by 4. Cancel D square, cancel X square, cancel D square by 4. So we can factorize. It becomes S2P minus S1P, one bracket, S2P plus S1P, another bracket, equal to 2XD. Therefore S2P minus S1P equal to 2XD upon S2P plus S1P. Therefore path difference equal to 2XD upon S2P plus S1P. As capital D is measured in meter and small d is measured in millimeter. So S1P approximately equal to S2P approximately equal to capital D. Therefore path difference equal to 2x small d upon capital D plus capital D, which is equal to 2x small d upon 2 capital D. 2 get cancel. So path difference equal to x small d upon capital D. It is considered as equation A. For bright band, we know that if path difference is integral multiple of wavelength, so point appears bright. Therefore path difference equal to n lambda. From equation A and equation B, x small d upon capital D equal to n lambda. Therefore x equal to n lambda capital D upon small d. For nth bright band, xn equal to n lambda capital D upon small d. It is considered as equation number 3. For n plus 1th bright band, xn plus 1 is equal to n plus 1 bracket close lambda capital D upon small d. Equation 4. Bandwidth is the distance between successive bright band. Therefore bandwidth is equal to xn plus 1 minus xn. From equation 3 and 4, n plus 1 lambda capital D upon small d minus n lambda capital D upon small d. Therefore n lambda capital D upon small d plus lambda capital D upon small d minus n lambda capital D upon small d plus minus n lambda capital D upon small d get cancel. Therefore bandwidth for bright band is equal to lambda capital D upon small d, is considered as equation C. For dark band, if path difference is odd integral multiple of half the wavelength, so point appears dark. Therefore path difference equal to 2n plus 1 lambda upon 2, considered as equation 4. From equation 1, that is path difference A, and equation 4, from equation A and equation 4, x small d upon capital D equal to 2n plus 1 lambda upon 2. So x equal to 2n plus 1 lambda capital D upon 2 small d, which is equal to n lambda capital D upon small d plus lambda capital D upon 2 small d. For nth dark band, xn is equal to n lambda capital D upon small d plus lambda capital D upon 2 small d. It is considered as equation 5. For n plus 1th dark band, xn plus 1 is equal to n plus 1 lambda capital D upon small d plus lambda capital D upon 2 small d, which is equal to n lambda capital D upon small d plus lambda capital D upon small d plus lambda capital D upon 2 small d. Therefore, x n plus 1 is equal to n lambda capital D upon small d plus 3 lambda capital D upon 2 small d. Equation 6. From equation 5 and equation 6, bandwidth for dark band equal to x n plus 1 minus x n. Therefore, n lambda capital D upon small d plus 3 lambda capital D upon 2 small d minus n lambda capital D upon small d minus lambda capital D upon 2 small d. Here n lambda capital D upon small d get cancelled. So, by subtracting here 2 lambda capital D upon 2 small d, which is equal to lambda capital D upon small d. Therefore, bandwidth for dark band equal to lambda capital D upon small d. Equation D. From equation C and from equation D, we say that bandwidth for bright band and dark band is equidistance. Question number 22. Draw a label diagram to study the photoelectric effect. And numerical, find the pressure of nitrogen gas at NTP. Density of gas is 1.25 kg per meter cube and velocity of gas is 489 meter per second at NTP. Here the solution of above question will be diagram gets 1 mark or experimental figure gets 1 mark and labeling gets 1 mark. So 2 mark for diagram and labeling will be there. And in numerical, first we see a given data. Pressure equal to question mark. Density rho is equal to 1.25 kg per meter cube. And RMS velocity C, RMS is equal to 489 meter per second. We know pressure exerted by nitrogen gas will be 1 upon 3 rho C square RMS. If we substitute the values P equal to 1 upon 3 into 1.25 into 489 bracket square. By solving using the log table, pressure is 1.0 approximately 1.0 into 10 raised to 5 Newton per meter square. Therefore, pressure at NTP of nitrogen gas is approximately 1 into 10 raised to 5 Newton per meter square. Question number 23. Define potential gradient. State its SI unit and dimension. A numerical is a particle is performing SHM of amplitude 5 cm and period of 2 seconds. Find speed of particle at a point where acceleration is half of its maximum value. So answer for this above question will be potential gradient along the wire is defined as the fall of potential in bracket potential drop from the higher potential end per unit length of wire is called potential gradient. Potential gradient is equal to potential difference per unit length. SI unit of potential gradient is volt per meter. Dimension of potential gradient is equal to potential difference upon length. So potential difference is work upon charge upon distance. Work is force into distance upon charge is current into time upon distance. So distance get cancelled. Force is mass into acceleration upon current into time. mass upon current into time into velocity upon time. Mass upon current into time square into distance upon time. Mass into distance upon current into time cube. So, dimension of potential gradient is square bracket L raised to 1, m raised to 1, t raised to minus 3, I raised to minus 1, bracket complete. We solve numerical. So given data is amplitude is given as 5 centimeter, which is equal to 5 into 10 raised to minus 2 meter. Time period is 2 seconds. Acceleration is equal to maximum acceleration upon 2, means a omega square upon 2. And we can find out velocity, v equal to question mark. We know that acceleration is equal to omega square x. So x is equal to acceleration upon omega square. So x equal to maximum acceleration upon 2 omega square, because acceleration equal to a omega square upon 2. Therefore maximum acceleration can be a omega square. When we put omega square get cancelled, so x equal to a upon 2. We know formula for velocity, v equal to omega square root of a square minus x square. V equal to omega square root of a square minus bracket means a upon 2 bracket square, means omega square root of a square upon 1 minus a square upon 4. By calculating, v equal to omega square root of 3a square upon 4, means v equal to a omega upon 2 square root of 3. We know that omega equal to 2 pi upon capital T. So v becomes v equal to a upon 2 multiplied by 2 pi upon capital T square root of 3, which is equal to 5 into 10 raised to minus 2 multiplied by 2 pi into square root of 3 upon 2 into 2. 2 get cancel. So v equal to 5 into 10 raised to minus 2 multiplied by 3.142 upon 2 multiplied by 1.732. By dividing, it becomes 2.5 into 3.142 multiplied by 1.732 multiplied by 10 raised to minus 2. By using logarithm, so here velocity equal to 1.360 into 10 raised to 1 into 10 raised to minus 2. It becomes 1.360 into 10 raised to minus 1 meter per second. So velocity is equal to 13.60 10 raised to minus 2 meter per second, or velocity is equal to 13.60 centimeter per second. That will be the answer for given asked question.